We have learned that inside everything, the tiny pieces are always moving, some slowly, some fast. So here is today's big question. What decides how fast they go? Let us find out with a glass of water. This water is cold. And when we zoom right in, look. The pieces are jiggling, yes, but slowly. Gently. They are creeping along, taking their time. And our thermometer over here sits nice and low. Now, let us warm that same water up on a stove. And watch what happens to the pieces. They speed up. They start zooming and bumping and jiggling like wild things. They are the very same pieces as before. We did not add anything new. We simply made them move faster. And that right there is the whole secret of heat. Heat is just how fast the tiny pieces are moving. Hot means fast. That is all. So think about what a thermometer really does. We always imagined it was measuring some special stuff called hotness. But no, a thermometer is really a little speed meter for the pieces. When they crawl, it sits low. When they race, it climbs up high. It is just counting how fast the invisible crowd is jiggling. And this tells us something wonderful about cold. Because if hot just means the pieces are fast, then cold simply means the pieces are slow. Cold is not a thing. There is no cold stuff. There is no cold that pours into a room. There is just one long line. Slow pieces at one end, which we call cold. Fast pieces at the other, which we call hot. And here is a curious thing. There is a coldest possible temperature, right at the very bottom, where the pieces stop moving altogether. But there is no hottest. You can always jiggle just a little bit faster. Now this fixes a mix-up that fools almost everybody. Imagine a warm cup of cocoa sitting in a cool room. We usually think the cold from the room creeps into the cocoa and cools it down. But there is no cold. There is nothing to creep in. So that cannot be right. Here is what truly happens. The fast pieces in the warm cocoa bump into the slow pieces of the cool air. And every time they bump, they share a little speed, the way a fast marble sets a slow one rolling. So the heat flows out of the cocoa into the room. The cocoa slows down and cools, the room speeds up a tiny bit, until at last, everything is jiggling at the very same speed. That is what same temperature means. So the next time you hold an ice cube and your hand feels cold, remember what is really going on. The cold is not coming into your hand. The warmth, the fast jiggling, is leaving your hand and flowing into the ice. You are not being filled with cold. You are giving away your heat. Isn't that a lovely way to think about it? Look at everything you understand now. Heat is just how fast the pieces move. Hot means fast. Cold means slow. And heat always flows out, from the fast pieces to the slow ones. You now know what temperature really, truly is. But now I am left wondering something. If warming the water just makes the pieces go faster and faster, what happens if we do not stop? If we keep speeding them up and up and up, do the pieces just fly apart? Does the ice melt? Does the water boil away and vanish into thin air? And if it vanishes, where does it go? That is one of the very best questions in all of science, and it is exactly where we are headed next time. See you there.